Hello all, as a continuation of my lecture series in special electrical machines, in this video we are going to discuss about the EMF equation of permanent magnet synchronous motor. So when we deal with EMF equation of permanent magnet synchronous motor, this is also called as permanent magnet sine wave motor, and first we are going to deal with flux density distribution. So as we all know, the working principle of any motor will be when the input supply is given to the armature winding, it produces a magnetic field which in turn produces a flux, and it will result in the parameter called torque. So this is the parameters, this is the main important parameters which we will be discussing. So here, based on the flux density distribution, we are going to calculate the EMF equation. So here we have two waveforms. One is clearly shows the B max. Flux density is indicated as B, and since it is a sine waveform with some angle, we are going to consider it as B sine P theta. Here we are going to consider at any instant a small angle called d theta, a small parameter called d theta. And here why we have chosen the center point is, which we call it as the maximum value, which is also called as amplitude. So when we deal with sine wave, we come across the parameters called amplitude, instantaneous values, and time period and frequency. So the amplitude is the maximum value of any parameter that we measure. So this shows the flux density distribution of the permanent magnet synchronous motor. So coming to flux density distribution equation, let us consider a small strip of d theta, which in unit mechanical per radiations at a position theta from the reference. So flux density of the strip will be B is equal to B max sine P theta. So this B max is the center amplitude value. Coming to incremental flux in the strip d theta, it is multiplied with the area by the conductor. So d theta is equal to B sine P theta into the area is indicated as length into radius, LR. So where L is the length of the armature and R is the radiance of the armature. So finally we have a d theta equation like B sine P theta into LR d theta, where the LR is if it comes to the front, then it will be B LR sine P theta into d theta. So this is based on the flux this is based on the angle equation where maximum flux density is multiplied with the area. Now flux enclosed by the coil after some t seconds, if we consider, then the angle becomes omega m plus pi by p. So let us integrate the d theta equation with angle 0 to omega m plus pi by p. Then the flux will become B max LR sine P theta into d theta. So when we integrate, then we will get 2B LR by P into cos P theta. So this is by integrating the flux equation. So this is about the flux distribution in permanent magnet synchronous motor. So coming to EMF equation of ideal permanent magnet sine wave motor, as we all know that from Faraday's law of electromagnetic induction, we can write the statement E is equal to minus N d phi by dt, where N is considered as 1 and d phi by dt. So minus d phi by dt into the value we can consider. So from this 2B max LR omega m sine P omega mt will be the EMF equation for sine wave motor for an ideal motor. So coming here, now let us consider a T phase number of turns. So the same the equation in terms of phase value if we write, then E phase can be written as 2B max LR omega m sine P omega mt into T phase, where T phase is number of turns connected in series per phase. Now we can, in order to simplify the equation, we can write 2 B max LR omega m is into one value which is capital E phase. So 2 B max LR omega m T phase can be written it as in one equation. Now we are going to consider the RMS value of EMF. So if it is RMS value of EMF, we have to divide the E phase voltage is divided by root 2. So the root 2 in the numerator we have 2, so that can be split in, written it as root 2 into root 2, so that one root 2 will be cancelled. So the final equation will be root 2 B max LR omega m T phase into omega m. So when we consider the phi m sinusoidal distributed flux per pole, then in terms of B average, the following equation can be written. So this by considering these equations, then root 2 by substituting the equation, we can finally get the phase EMF as 4.44 F phi m into T phase, where F is the frequency, phi m is the flux, and T phase is the value number of turns per phase. So this is how the EMF equation is derived. Now let us have an assessment, a simple question with synchronous motor. A synchronous motor is said to be dash as draws a dash current when the voltage is less than the back EMF. So when the voltage is less than the back EMF, the synchronous motor will be overexcited and the current will be leading. So the answer is 4. So in this video, we have discussed about the flux distribution, and we have derived the equation for EMF of a permanent magnet synchronous motor. Thank you.